We are going to begin the keynote panel now, and I'm very pleased to announce that in addition to the 600-odd people that registered to be here, this is being webcast, and the webcast is being watched in 39 countries, including Kazakhstan, I'm told. So I think you may want to moderate your remarks about Kazakhstan. Were you planning to make any? It's my privilege to introduce our panelists today, Bill Reinert of Toyota Motor Sales and Michael Wirth from Chevron, along with our moderator, Professor Robert Topel. First, Bill Reinert. Bill is the National Manager in charge of the Advanced Technology Group for Toyota Motor Sales USA. He's responsible for the long-range product planning for all alternative fueled Toyota vehicles. This includes product planning for hybrid vehicles, including the new Prius, and cross-car line hybrid issues, fuel cell vehicles using both direct hydrogen and fuel reformation designs, full-featured electric vehicles, and city electric vehicles and sustainable transportation systems. Thank you, Bill, for being here. Our next panelist is Michael K. Wirth. Michael is Chevron Corporation's Executive Vice President for Downstream and Chemicals. He directs the company's worldwide manufacturing and marketing of chemicals and Oronite additives, as well as lubricants, supply, and trading businesses. Previously, Michael served as President of Global Supply and Trading, where he led the corporation's worldwide supply and trading operations, as well as its aviation, marine, and asphalt businesses. We are very pleased to have you here, Michael.
Thank you.
And leading our discussion today is our moderator, Bob Topel. Bob is the Isidore Brown and Gladys J. Brown Distinguished Service Professor in Urban and Labor Economics at Chicago Booth. Since joining the university in 1979, Bob has studied many areas of economics, including labor, industrial organization, and antitrust, business strategy, health, energy, national security, economic growth, and public policy. Bob has written several books and more than 60 articles, including co-authoring The Value of Health and Longevity, which won the 2007 Kenneth J. Arrow Award for the best research paper in health economics and was published in the Journal of Political Economy. As I mentioned earlier, he is a co-director of the Energy Policy Institute at Chicago, launched by the university last year. And it's my pleasure to welcome all three panelists. Please join me in thanking them. Bob, you have the floor.
Thank you, Sunil. One of the things I want to point out about Sunil's comments is that he watches the wrong movies. He should have been watching the Jetsons. And you might hear a little bit of some Jetson-like stories from Bill as the hour goes on. He also did the introductions for both Bill and Mike, which is great. And I'll just tell you one other thing about them. They were both recently honored as two of the most distinguished graduates of UFC engineering program at the same dinner. And for those of you who are in the know, you know that, well, the University of Chicago doesn't have an engineering program. So in this particular instance, it refers to the University of Colorado. But like our policy on Nobel Prizes, where we lay claim to anybody who stopped in Hyde Park for directions, we will let the initials justify the accolade. Now, our topic for today is the future of transportation, and particularly the future of transportation fuels. And I got to know these two guys because we serve on a task force for the National Petroleum Council at the behest of the Secretary of Energy to study the future of transportation fuels and their use in the United States. One of the questions that the Secretary asked is there any prospect with all the technologies available and the alternatives that might arise for reducing greenhouse gas emissions from U.S. transportation by 50% by 2050. And I'll leave it to my colleagues up here to provide their answers to that question. So let me give you some background. As we all know, oil's been the dominant transportation fuel in the transportation sector, both in the U.S. and abroad over the last century. Light-duty vehicles and heavy trucks account for about 80% of the greenhouse gas emissions in the transportation sector in the United States. In 2010, there were about 75 million of these vehicles sold worldwide. It's a number I hadn't expected. The global stock of light-duty vehicles was about 830 million, and about 230 million of those are in the United States. And at current turnover rates, it would take about 17 years to replenish the stock that we're driving. The U.S. consumes about 14 million barrels of oil per day in transportation. Imports account for about half the total, but that's been declining since about 2005. The government has set a target, as I said, of trying to reduce emissions by 50%, greenhouse gas emissions by 50% by 2050. So some of the questions we'll ask here are, what are the factors that will influence oil and alternative fuel development and prices in the coming decades? How are prices and incentives to innovate affected by world economic growth? How are regulations and government policies impacting energy sector strategies and investments? We have the people here who can answer those questions. What are the foreseeable changes in transportation technology, and how will those changes affect and be affected by relative prices of fuel and alternatives? What types of technological breakthroughs are necessary in order to push transportation methods towards one type of platform or another? And what are the most useful policy tools that might influence technological developments and incentives to innovate and to use different types of transportation fuels? If the government is to play a role, what role should that be? So let's begin with Mike. Mike's in charge of Downstream for Chevron, but you can bet he also knows a lot about upstream and where the stuff is and the prospects for getting it. So how do you see the oil market evolving over the foreseeable future, especially in regard to world economic growth, the emergence of alternative sources of transportation energy, and government policies?
That's a very narrow
question
to start
I thought
with.
I'd use both sides of page if necessary.
I didn't know this was an exam. So I think one place that's really useful to start is scale. And I think it's one of the least well understood issues about energy in the whole dialogue is the scale of the energy system in the world. And if you think about it, just look around where we're sitting right now. We've got lights, we've got air conditioning. Everybody got here today. Some of you may be on foot, but I would bet most of you some other way. The world uses over 550 quadrillion BTUs of energy every year. Now, I don't even know how many zeros there are in a quadrillion, so don't put that on the test. But the energy system in this world is massive. If you translate it into barrels of oil, the current primary energy, so this is for power, this is for transportation, heating and cooling, is the equivalent of about 300 million barrels of oil every day, or 12.5 million barrels of oil every hour. 525 million gallons of oil every hour to keep the trains running, the lights on, the air conditioning going. It's a massive system to support the economic activity and sustain people around the world. And it works reliably, works efficiently, it's affordable, it beats all the alternatives, or the alternatives would be in there. So in that massive system right now, about 30% of the primary energy usage is oil, about 30% of it is coal, about 20% of it is natural gas, and the remaining 20% is everything else. Nuclear, hydro, solar, wind, biomass, biofuels. And it works every day. 20 years from now, we're going to need 40% more, because there are only about 1 billion people out of the 7 billion people on the planet that live like you and I do, that enjoy space heating and cooling. The lights work when you put the switch on. You cook with modern fuels as opposed to primitive fuels. You have mobility. You have health. You have all the other things that an energy system supports. There's about 2 billion people on the planet that are on their way, the emerging middle class in some of the developing economies of the world. but they're not there yet. And really all they want is the lifestyle that you and I take for granted. And then there are about 4 billion people on the planet that have very little chance of ever in their lifetime seeing the kinds of things that you and I take for granted. So it's a massive energy system to support the world, and it's going to grow tremendously. Any forecast you look at from anybody, and you don't have to look at somebody in the petroleum business or the energy business, would tell you that 40% demand growth is going to happen over the next 20 years, and that the overall mix is not going to change very much. The fastest growing piece of that mix will be renewables. Renewables today, wind, solar, and biofuels, represent about 1% of that 300 million barrels a day. 20 years from now, it will represent 3% of the total, and it will be the fastest growing piece. But there are tremendous challenges of scale, of investment, of infrastructure, of time, of technology that need to be addressed. And the system that we have today took over a century to evolve and trillions of dollars of investment, and we will transition off of hydrocarbons. It's inevitable. It will happen. The question is when and how. And that's to Sunil's opening comments. Predicting the future is hard. But it will happen. But it will happen gradually, and it will happen through sustained investments in research and development and technology, and it will happen in a transition. It's just the same way we moved off of, 100 years ago, a quarter of the farmland in this country fed horses. And those horses were used for transportation. And that was the primary source of transportation 100 years ago. Now you have less than half that amount of land consumed in all the refineries, all the oil wells, all the roads, all the highways in this country for transportation, much less land allocated to it. But it took us a century to get here. And a century from now, when my great-grandchildren are having a discussion at the 160th Booth Conference, no doubt the energy mix will be quite different than it is today. But it will take time, and it will take tremendous investment. And so we really have to recognize those issues of scale and investment and time as we contemplate these kinds of questions.
So when you say there'll be 40% growth, but you also say that hydrocarbons will be a much smaller fraction. I think you even said will be translated off of hydrocarbons for transportation. How is that affecting Chevron's strategies, its investments, what energy alternatives you guys are looking into?
Well, for all of you here in the business world, you have, at least if you're a publicly traded company, you have shareholders and you have competitors. And so in the first instance, you have to compete today. And that's where our primary focus is directed. But we're a big company. This week, we'll spend $600 million in capital to bring new energy supplies to the world. And next week, we'll spend $600 million. And the week after that, we'll spend another $600 million, because this year, our capital budget is $33 billion. So we spend $600 billion a week to bring new energy supplies to the world. Primarily, they're the energy supplies that are needed to meet your needs tomorrow and next week and next month, which reflect the current mix. Now, at the same time, Chevron is the largest geothermal energy supplier in the world, and that is the cleanest energy you will find. There's no worry about disposal of waste like there is with nuclear. There is no combustion. We bring steam up from the earth, and you run it through a turbine, and you generate electricity. It's tremendous. It's great from a greenhouse gas standpoint. And we're the largest producer in the world of geothermal energy, and it's a profitable business. We actually can make money at that. We've got solar investments. We just started up a solar project in Southern California. We've got 65 acres of mirrors that every day, like a big sunflower, open up and turn to the east, and they track the sun, and they direct the sun's rays onto a boiler that sits 300 feet in the air to generate steam. We've got windmills. We've got a joint venture with Weyerhaeuser where we're working to use forest residues and forestry-based products to create biofuels. So we invest across the spectrum. Our investments represent markets today and our belief about where there will be economically competitive, sustainable, viable energy sources for the future that don't rely on subsidies, that can compete in a world that needs affordable, abundant, and reliable supplies.
Thanks, Mike. Let me turn over to Bill here.
I was hoping he'd go longer.
When I first was told I was going to meet the guy who's sometimes called the designer of the Prius, I pictured a guy with a pocket protector and a short sleeve white shirt, but it didn't turn out that way. And he once told me that his job is to think about what vehicles and transportation will be like 25 years from now. So, and he drives a hydrogen-powered vehicle to work every day. And I want you to work in the story of the Jetson Google Prius somehow. But where do you see the energy mix in transportation and the types of vehicles we drive, both in light-duty vehicles, heavy-duty vehicles, and the like? Where's that going to be going over the foreseeable future?
Okay, over the foreseeable future, you have to understand that whatever's in the pipeline now, most of the technologies that we know about out to 2020 are already in the pipeline. So for our 2020 cars, we're really kind of picking out the wood grain and that kind of stuff. So really what we look at is for our long-term stuff is post-2020, and we try to get our budget set for R&D. And we spend about $1 million an hour on R&D, so it's serious consequences. So I think that in the near, and we work a lot with the DOE and with media in Japan, and I'm leaving for Europe tomorrow or tonight and work with the EU. So specifically, we're going to be oil and gas for quite a while, out decades. I know a lot of people thought that batteries were going to work, but if you really look, try to make a business case for just a pure battery electric car, not a hybrid car, but a pure battery electric car, it's really, really tough to make that business case. But our cars are going to become much, much more efficient. Right now, the average car you drove in today has an efficiency of about 17 to 18% from the gas tank to the wheels. If you drove a Prius, it's about 34%. That's the increase because of the electric powertrain. We're spending a lot of money to reduce the cost of the electric powertrain, to reduce the size. But when we go to Japan and we show our advanced engines, and all companies have these advanced engines, in the next decade we're going to come out with engines that are 2 to 2.5 times more efficient than the ones you're driving today. And so to understand that the fleet MPG is going to increase drastically over time, probably not from a regulatory point of view primarily, but from a development point of view. It's true, we're going to. The thing you need to calculate, though, as we start looking at that, is not how much fuel you're saving, it's how much fuel you've used. And when you see that the difference of going from 50 miles per gallon to 60 miles per gallon saves you, I don't know, 200 or 300 gallons per year. Really not really worth the price of doing that. But we need to move the heavy-duty stuff, the big trucks and the heavy SUVs. Those are the ones that you need to move up and to take advantage of it. So now I'm driving an SUV, but it's a hydrogen-powered SUV. I've driven it for like 12,000 miles. I drive it up to 50 miles each way up to 405 in Los Angeles. And I get about 60 miles per gallon of gasoline equivalent. And I think that the oil companies can make us hydrogen right now from steam methane reformation at the refineries. And it's going to cost us about $5 to $6 per gallon of gas equivalent to run the hydrogen. And with some help from the governments, with some help on infrastructure, you ask about that, I think we could see hydrogen cars start to make a small inroad about 2020-ish. I think you're going to see a lot of natural gas come into play in the big heavy-duty truck industry, probably from a liquefied natural gas. I think it's a hard case to make a compressed natural gas play right now in the big trucks. So those are the kinds of things. Much more efficient. We're doing lightweight. We're taking the weight out. Ford's really making great progress in doing that. We're probably not going to go to exotic materials like carbon fiber. We're going to do advanced steels and hybrid type of steels and know how to structure our cars to make them safer and lighter at the same time. And new ways of welding, laser welding, and bending the sheet metal with water so we can get much more precise angles in the car. So that's mostly the near-term stuff.
Okay, so in terms of where government policy is going, both of you, you can't answer, we like the government policies that benefit us.
Well, I really would.
Yeah, I know you would.
It doesn't.
But what types of policies would be most effective in affecting the mix? And then I have one broad question for both of you, which is the question that we got from the Secretary of Energy, which is, what are the prospects for reducing greenhouse gas emissions by 50% by 2050?
Okay. Let me ask the last question first. If vehicle miles traveled continue to grow at the rate they're growing, you know, driving more, populations are going, if that continues, the chances of actually hitting the 50% target are quite grim. I don't see how you can do it. We can take the carbon out of the tailpipe. Michael can work and take some of the carbon out of the fuels, and together we can get pretty close. But that gets overwhelmed if you've got carbon in India and the emerging economies, as Michael said. That gets overwhelmed regardless of what we do in California and in the US, regardless of that. Now, as far as government policies, right now in the state of California, we're very strongly regulated, in some of the other states, and at the federal level, it's a regulatory push, okay? And so the regulations cause us to design in a certain direction. The regulations aren't necessarily descriptive, they're prescriptive. You have to do this kind of car, and we want the car to have so many electric miles, and it's got to plug in, and it's got to do that. Rather than saying, hey, these are your targets, we're bright boys, leave us alone and let us go design it. So what I'd like to see is continued long-term funding of the national labs, Sandia National Labs, Lawrence Berkeley, NREL, National Renewable Energy Labs, Argonne, those labs. What their funding comes on and off every year, political cycles. And when that happens, you've got all the scientists and the postdocs that gear up for a project, and by the time they actually start the project, the funding's collapsed and the team goes away and goes back to the universities. It's extraordinarily frustrating to work as collaborators with the U.S. science right now because of the cycles of funding. And that's basically set up because of congressional budget rules. If we could fix that and lay out a 5-year, this is what you're going to get, okay, now let's bring industry in and let's work in collaboration, we could do so much better. So that's what I think the role of government would be, is to help us with the pure research, because mostly Chevron and Toyota are pretty much independent about, you know, doing our own engineering. We don't need a lot of help, just the long-term stuff, the high-risk stuff.
So I'll give a quick answer, because I agree with virtually everything that Bill just said. If we were to shut down every vehicle on the planet today, every car, every truck, every ship, every train, every subway, every airplane, you would reduce greenhouse gas emissions by about 15%. You'll have to get on your bicycles or your jogging shoes. But so and this is in today's world before you get all the growth and the emergence of these economies around the world. And so these goals that are put out there are often based in good intentions and a belief that this is an issue that needs to be dealt with, but they are not grounded in any realistic assessment of the situation. And so I think the odds of a 50% reduction by 2050 are very, very low, because we have, as I said, there are billions of people on this planet that are moving up the scale of lifestyle, and they will consume more energy to do that, and it's inevitable. You cannot turn back the tides of progress in these parts of the world. So I think that's a low likelihood. On the what can policy do, I will tell you what doesn't work very well, and that is the government picking winners. And just as Sunil started out, you know, Arthur C. Clarke, who was a pretty visionary guy, he missed the cell phone, and he got it wrong on the moon base for the hop over to Jupiter. Predicting the future is not easy. And picking winners in technology, even if the government were completely uninfluenced by any other interest groups, is damn hard. The reality is, when the government comes in and tells Toyota what kind of cars to make, it's not doing that in a purely scientific and engineering and economic frame. It has other objectives. And so the selection of winners and losers by the government is not a good policy. On the other hand, the funding and the consistent funding of fundamental research and development is what has made this country strong over its history. And continued funding of fundamental research on the issues that can lead to the breakthroughs and lead to some different solution than what any of us would pick out today as the likely, that will pay off. And so I completely agree with Bill. The national labs need to be funded. We need to have a framework of setting aggressive and challenging targets for industry, whether they're the performance of vehicles and fuels, environmental performance, but we can't have people prescribe solutions, because that presumes that they're smarter than the innovators at Toyota and the innovators in the national labs and the innovators in the energy industry. And I just fundamentally believe that that's not true.
Well, the way an economist would put that is that private industry is not so good at basic research, but they're really good at applied research.
That's right.
And the reason they're not good at basic research is that ideas are public goods, and once it's invented, anybody can use it. So the government has to be in the business of putting its money somewhere for basic research.
Right.
Where would you guys put it?
Today?
Yeah.
Right now, in the context of what I see in the few years I have remaining in the industry, I'd like to see the government putting into low carbon hydrogen production, either through solar thermal like we're doing down with Chevron, water splitting, something like that. Low carbon hydrogen looks to be pretty good. We pretty much got the fuel cell part of the equation knocked out. We understand how they're going to work in minus 50 degrees below zero. They actually work better than an internal combustion engine. I'd like to see them come up with liquid fuel replacements that Chevron can make money on that reduce the carbon even further. Those kind of things.
Yeah, I think that the government needs to take a portfolio approach on the research side too. And there are a number, in this study that Bob referred to, has identified a number of potential pathways and a number of different scenarios and evolutions on vehicle and fuels technology that hold promise and that potentially could work, but there are also hurdles to be overcome. And so I think the government needs to invest in a portfolio of technologies, from materials research to fuels research to the manufacture and distribution of some of the fuels, and then steadily, consistently invest in that and allow the smart people in the national labs and other places to get out of the funding cycle and into the long-term business of using what they're good at to find the breakthroughs that enable the next brilliant person to ultimately apply these things in a way that can work at scale and be competitive and affordable over the long term.
Now, Bill, when I first met you, I thought this is he heads the sub-task force on battery-powered vehicles and electric vehicles, and I thought this would be the guy who would tell me that battery-powered vehicles were the way of the future. And then when I saw the first report, I can't tell you all the details, but there are little bubbles about technologies we know about and we can get there, and technologies maybe we need a small breakthrough, and technologies where we need to get over a huge hurdle. Can you say something about like the breakthrough technologies that would have to occur to make purely electric and battery-powered vehicles a viable alternative?
Just for the car, just for designing the car. Okay, so the way that the regulatory agencies view the cars now, the electric cars, they view them as any car that's got a battery and some motor and the wheels is a desirable car. And I was involved with the Prius when it was first launched, and the first one didn't sell very well, and we started looking at it, and the back seats didn't fold down. So young married couples, like many of you here, that have baby strollers couldn't buy our car because the baby strollers wouldn't fit in the car. So it's a real estate gambit. When we design a car, you fix the wheelbase, you fix the engine, and then you start designing it for the cars, knowing that families want to adapt to how cars use. Batteries are very difficult to use that way because they're so hard to get the energy density down to where we need. In fact, physically, we're at the physical limits of what we can do with batteries. So from a technical point of view, that's a long, hard road. And really, I don't think that you're going to see a customer pull or an economic value proposition for electric cars outside of urban areas. I think inside of urban areas, I can work with Zipcar and other people to do transportation things. So that'll work that way, and I think it's okay. You'll see a lot of speculative talk about replacement batteries and maybe a zinc air or a lithium air and that kind of stuff. Those batteries are a long ways off. When somebody says they've got a battery in the lab, that means the battery itself is really about the size of my finger. And there's some electrodes coming in. So by definition, it's a battery. But it's a long way from the battery pack and putting it in a car and all the air conditioning for the batteries that we have to do. So that's the technical stuff. Unfortunately, what we've done recently, though, is our regulators have gotten in front and quite a ways in front of the society's preparation and readiness for this kind of technology. And so you see a lot of money on the table. I think it's $10,000 a car or something like that. And you see the sales continuing to be not very strong. We didn't do a very good job of preparing society for it, from a rules and regulations, from a utility point of view, how these cars interact with the utility, how you get the carbon out of the utility, where the transformers go. Some of these cars require a great deal of energy to charge them. Those kind of things, and even the business model of a company like Better Place or a Coulomb coming into Chicago and competing against your local utility here, those kind of things have to be thought through, and they're either going to be thought through at the Public Utilities Commissions, or they're going to be thought through in the court of law. So that's the kind of stuff that we really need to think about. And unfortunately, we should have thought about it 5 or 6 years ago, and now we're kind of out there making things up as we go along. That's a little bit harsh to say that, but there's a lot of stuff going on to kind of catch us up.
So if you had to look out 20 years, what fraction of your portfolio of energy use will be supplied by these guys? And you should answer the same question.
Well, Michael mentioned biofuels, and I think that's a broad. We can talk about biofuels, but I would say liquid fuels, and I assume that we're still going to be getting them from Chevron and other liquid providers. I think liquid fuels will still be somewhere in the 70 to 80% in 2 to 3 decades, somewhere around that.
Bill made reference to the fundamental reason that liquid fuels are so prevalent in society today, and that's energy density. And if you look at batteries and you look at all these other technologies and you look at a gallon of gasoline, the energy density, the portability, the shelf life beats everything else by a long way. So I hate to disappoint people that think there's some cabal that has made oil unassailable, but the fact of the matter is it's thermodynamics and physics, and the energy density of liquid fuels and the portability of liquid fuels is what is still the thing that these other technologies can't quite crack. I put in, early in my career, I'm an engineer, and I used to work in our retail business, and I built service stations. I built natural gas refueling stations in Houston, Texas, with compressed natural gas. And we opened them up with much fanfare from the local politicians and regulators and the EPA and dignitaries, and there were balloons and cake and news media and everything. And I would come back because I was responsible for maintaining these things and monitoring them, and no customers ever showed up. And there were programs to incentivize people to put in compressed natural gas fueling in their vehicles, and it's been going on forever, for decades and decades. And there are big parts of the world where there are fleets that run on compressed natural gas. But you need big cylinders, they're bulky, they are heavy. Taxis in many parts of the world run on compressed natural gas. But if you show up for a CNG taxi, you better not be carrying a very large suitcase because there's no room for it. And they go back to a common refueling point at night so that they can be refueled, and they can be refueled slowly because to refuel them rapidly takes different kinds of compression. And so there are these issues of infrastructure and economics and utility that are often overlooked as people declare a certain technology promising. The reality is most people buy a vehicle for very utilitarian reasons. And if they can't get the stroller in, or they can't get to their daughter's volleyball game or softball game and back, that car's not very useful. And so I think the real challenge is recognizing that these technologies all ultimately have to serve customers. And I live close to Berkeley. I went to school in Boulder, so I go, in Berkeley and Boulder and Boston, you see a disproportionate number of some of these advanced vehicles, and they're typically somebody's third or fourth car, and they're used for very specific purposes. But they've got another car that's the primary car for the things they really have to do that are outside of the narrow range where that vehicle is applicable. And that's great for the people that can afford it. The reality is most of the world isn't there. And so we have to recognize these practical realities about how people behave and what they're looking for out of transportation.
Let me give you an example of what energy density works out. Okay, so the gas tank on a Prius is about the area with this table and about that deep. And it can take you 400 miles. It takes you about 5 minutes to fill it up. And we can mold them out of plastic for about $400, and they weigh about 40 pounds in the car. Okay, very simple. Now, if I want to do a battery to take you 100 miles, first of all, it's going to have to charge all night at 240 volts. And it's going to weigh in the neighborhood of 800 to 1,000 pounds, and it's going to cost in the neighborhood of $10,000. That's the difference that we're up against right now.
Now, Bill, we've been talking about technologies where we affect either the type of fuel used or the efficiency with which we use it. But you've also talked in the past when we've been together about different modes of transportation. And I know you told us a story about the Google outfitted Prius you were in last year, and other automated ways to have people weave into traffic, and what the efficiencies might be there. What do you see happening in that dimension?
Well, I think that there's several companies that are working on automated cars. And you mentioned Google, but there's other companies that are working on it. In fact, the state of Nevada now have passed the first law to help bring automated cars onto the market. So I don't think it's, I mean, you've got some brilliant technology companies out there, and driverless cars or the way that these could evolve are interesting. But how they come to the market is also interesting because of product liability. So as long as there is a 3-ton pickup with a drunk guy in the wheel, as long as that's on the road competing against your automated driving car, it's, from a liability point of view, it's very, very difficult to make the transition. So the transition probably comes as a augmented cruise control. You're already starting to see this lane keep assist, so you start to drift out of the lane, the car will pull you back. Some of the cruise controls are so good that you don't have to touch the gas or the brake. You put the cruise control on, the car will stop for you, accident avoidance systems. So this will come up as safety systems over time. And I think that's some of the technology. I think some of the other technology is, excuse me while I get this prop, nobody leaves home without their iPad. My wife doesn't, and she'd rather have the iPad than be mobile. And most of the kids, if you look at the young people today, the number of people that are 16 to 22 who could get driver's licenses and don't is accelerating, and that's because people would rather be connected than mobile. And so you're starting to see things like group-owned cars. Scott from Zipcars here, they were one of the pioneers. There's other people that are doing it. And so that's one of the technologies we're very interested in, or approaches we're very interested in, is how the car intersects with the urban environment, how the car intersects with the connected world. And those are very interesting things to study.
So, Mike, we're not going to get to 50% reduction in greenhouse gases, at least with foreseeable demand and technologies. And you're a downstream guy, but I also know you know about upstream. And a lot of people talk about peak oil and what's going to happen to prices. Are we anywhere close to peak oil? Is there a lot of stuff out there? Is it recoverable?
It's a fascinating question, because in this whole area of energy supply, and we've talked a lot about technology work and breakthroughs or potential breakthroughs in batteries or hydrogen or these other areas. In the energy world, I think the single biggest technology game changer, and it is a game changer, in the last decade has been directional drilling and hydraulic fracturing. And you've probably all read a lot of stuff about this, and there's some information and there's some misinformation out there. But we can take a drill bit now, and I don't have my distances here in Chicago all that well understood, but I would say we could take a drill bit, sink it down here, and go over and bring it up under any single seat in Soldier Field that we chose, and pop it up right under that particular seat. 20 years ago, we could only drill in one direction. We could drill straight down. We couldn't turn, we couldn't snake, we couldn't. Now we can find ways to access subsurface geologies that before you could only get things to flow into a vertical wellbore. And then the other thing that's done is you can now work through these long horizontal layers of hydrocarbon-bearing rock, and we can pressurize them to create kind of spider web window pane cracking through what is fairly dense rock. And the gas can flow through there, and the oil can flow through there. And it's fundamentally changed. It's why, people thought that the U.S. had seen peak oil decades ago, and that we were inexorably in decline, and that the United States was running out of oil fast. As you said, oil production in the United States has been growing for the last several years, and it will grow faster next year than it's growing this year. So we've seen tremendous changes in technology that create access to new resources that have always been believed unrecoverable. Over the last 3 decades, while there's been a lot of concern about peak oil, the recoverable reserves in the world have increased 30%. We've got 2.5 trillion barrels of recoverable reserves in the world, which is 70 or 80 years. And these are defined under very technical guidelines that you have to prove the economic recoverability and the technical recoverability. So, the world is running out of oil because it's a finite resource, and as we use it, it's not quickly replaced. It's very slowly replaced by geologic processes, and we're not that patient to wait. So we are running out of oil, but peak oil is a long ways out from a technical and economic standpoint. The biggest challenge really is policy. And whether it's policy in Venezuela, policy in Russia, policy in the United States, that is a greater threat to the ability to bring supplies to market than the existence of the resource, really for the rest of this century.
So go a little farther with this, because you caused a synapse to fire. On national security and the security of our oil supplies, or our energy supplies generally, are we more secure now? Are we less secure now? What are the challenges for maintaining our energy security?
Well, I'm glad you used the word energy security because oftentimes you'll hear people talk about energy independence and say if we could just be independent and totally self-reliant, then we don't have to worry about the rest of the world. And this is a room full of smart business people. The world is an interconnected place, and you can't just opt out and isolate. There is not an energy independent country on the planet. That includes the countries in the Middle East. There is nobody who is completely self-sustaining on energy. They move supplies back and forth across borders because the economics suggests there's a more efficient place to produce it, and so people don't invest to become totally energy independent. Energy security comes from being able to depend upon reliable, affordable, abundant supply, and that comes from diversity. That comes from diversity of types of energy. It comes from diversity of geographic sources of energy. And being a strong producer yourself is a good thing, but also having a robust and diverse set of supplies is very important. Most people think that the United States is somehow an energy lightweight because there's this anxiety about imports from the Middle East. The United States is the largest producer of biofuels in the world. The United States is the largest producer of power in the world. The United States is the largest producer of coal in the world. The United States is the third largest producer of oil in the world. The United States has an enormous abundance of energy resource, unlike anybody else in the world. And so we don't have an energy independence fear, or even really, as long as we have sound policy and support a diverse set of supplies, I think energy security. Now, energy prices and markets can fluctuate based on supply, demand, risk, the value of the dollar. There's a whole host of things that drive the price of oil. But the only time this country was insecure and you had to queue up in a line to buy gasoline based on whether you had an odd-numbered or an even-numbered license plate was when we had policy and political events intervene. And that's the risk to energy security, not supply.
Thanks, Mike. I think we've reached the point, and I just got the nod from the back, that for questions from the audience, we have a couple of microphones set up so that if people could, should everybody make their way to a mic? And there's one back there, is that right? Yep. And is there another one?
There's another one over here? Yes.
Can you hear me?
Yes.
Oh, yeah.
I'm Carl Bushman, a Booth alum. My question is, what is the future of coal gasification and its possible impact on the transportation sector?
Are you talking specifically about Fischer-Tropsch gas to liquid from there, or coal to liquids, that kind of stuff?
All of the above.
Okay. You've got some water uses, and that's also going to confound some of the biofuel stuff. You have to look at the Colorado River drainage and what that means to the whole western United States, and that's somewhat confounding there. I think Fischer-Tropsch have the Fischer-Tropsch. If you guys don't know, it's how Germany made oil at the end of World War II. You can make a very fine fuel out of coal, out of natural gas, out of a lot of things through this Dr. Fischer, Dr. Tropische, and that's what the Germans created, and it was developed later by Sasol in South Africa, and some other companies do it. It's interesting. It makes it, for us, a very neat fuel because there's zero carbon in it, zero sulfur in it, which means that I can bring in my best catalytic converters that would normally be poisoned by sulfur. It's got a high octane, which means I can bring my very best engines that need a higher octane or my very best diesels that need a high cetane. So very, very fine fuels come off of these. The problem is it's expensive. It's not even competitive with tar sands right now, which about sets the upper limit of where we're going to be. And it's pretty high carbon burden right now. And coal extraction, you got to be careful how you do it and working on the seams. But still, I'm relatively long-term, modestly positive about that direction. Modestly positive.
Bill's got it exactly right. It's technically doable. In fact, Sasol has coal-to-liquids refineries in South Africa today. It's very capital intensive. It's very water intensive. It's very energy intensive. And it really evolved in South Africa when they were under sanctions and they needed to generate supplies in country because there were trade barriers that didn't allow them to trade freely for their energy supplies. It's a long way from being competitive. There are a lot of other things that will come into the mix, I think, before coal-to-liquids. I think one day, as Bill says, I think one day it probably will be a bigger part of the mix, but that's quite a ways out.
When we start talking about methane, though, keep your eye on what's happening up in the Arctic and off the coast of Japan on methane hydrates. That's really interesting and frightening at the same time.
Do we have someone back on the right?
Not
Everybody's on the left. Here we go.
There's no line on the right. Get to the front.
I had a quick question. You talk about funding basic science research in national labs, but the transition from basic science research to applied science, it's non-trivial. How would you go about suggesting from a business perspective, how do you approach scientists who are doing basic science research to incorporate that science in a business fashion?
Sounds like a question for Bob.
Okay, so
Give them a piece of the action.
we work with the national labs as much as we can under a government document called a CRADA, which is a cooperative research agreement. And the interesting thing there is because we are working with the U.S. government that represents everybody, but yet we've got a lot of skin in the game as we go down there. And the key here is intellectual property. How does the intellectual property go into the public? Who owns it? If we paid for it, maybe we own it. How long can we own it? So that's really an interesting discussion to make. Once the property is done, we're going to be very good. Toyota has research in Nagoya that's called Genesis, just pure research, and then Toyota Central Research and Development, and then that comes from there into the engineering side. So it goes through 3 levels, and the process is maybe 10 years to come down out of the labs into the engineering side. But I think in the future, and for you, the business schools here, is how do you wrangle the intellectual property back and forth? As we start to go into electronics, that becomes a very compressed a body of knowledge, and it probably starts talking about manufacturers starting to team together on certain technology, and it's going to be very interesting to see how that comes out in the future.
The one quick thing I would add is universities have the same issues, and how can they transfer technology out in the public domain? Can they keep a piece of the action and manage to generate revenue off that intellectual property? The venture capital community is pretty good at reaching out and finding some of these things and placing a portfolio of bets on emerging technologies, knowing that most of them will fail, and if they can hit one, it can cover the rest. Our company actually we have a venture capital arm, and so we have an internal VC company that invests a non-trivial amount of money every year alongside of other VC firms into some of these emerging startups, looking to accelerate that very same process.
Some of the neat stuff that he's talking about is coming out of Scripps down in San Diego and into the University of San Diego, and it's genetic restructuring, and there's just a whole broad field of how you restructure single-cell organisms to make synthetic fuels.
We do have someone back on the right.
Chris Richardson, I'm graduating from Booth in 3 weeks or so.
Congratulations.
Thank you. Question for you both. Bill, you mentioned LNG for use in big trucks.
Yeah.
Obviously, that's dependent on the LNG fueling infrastructure. And
Yeah.
I was just wondering if you guys had any suggestions, either from a policy or an industry perspective, on how to sort of solve that chicken and egg problem, how to get the natural gas engine manufacturers to continue to build and also continue to grow the LNG fueling infrastructure?
Well, because I go to Japan a lot, I'll just tell you, what's going to happen in Japan this summer is going to be very interesting. As they've just last week shut down their last nuclear reactor, and they're going to move to their old oil-fired turbines now, and it's going to hit the oil market at about, I think, 300 to 400,000 barrels a day to replace the nukes. They can't do that forever. The plants are old. They're very inefficient. It's highly polluting, and it really rolls the oil markets to turn this on and off. The solution then is to go to combined cycle natural gas, and to go to combined cycle natural gas means that we have to start finding a way to get the LNG into Japan, and we've got such an allotment of it here in the United States. We could be a primary LNG supplier, and off of that would be some of the, you could see at the Port of Long Beach or up in San Francisco, you could see LNG plants, and off of that then would come the feeder industries for the trucks and transport. It's doable, but it's a long road.
Yeah, the thing I might add is when you talk to the manufacturers of heavy-duty trucks, one of the things that goes into the purchase decision for somebody who owns a fleet of trucks is the residual value of that prime mover after they're finished with it. And in this country, when you retire a heavy-duty engine, it typically is resold into an aftermarket, oftentimes outside of this country, and they harvest that residual value, and then that, is part of their overall life cycle economics. If you invest in an LNG-fueled prime mover and there is no aftermarket for it, you've got to take the whole cost of that thing across the life of that engine. And so that's one issue that has to be addressed. The second one is this chicken and egg thing on infrastructure. And I think what you're likely to see, and there's certainly a lot of people now seeming to focus in on this, is to find some regional corridors where there is heavy back and forth traffic of these kinds of vehicles, and find a way to kind of bootstrap some of the infrastructure in there so you don't have the experience I described where you invest large sums in small scale liquefaction is technically feasible. It exists in the world today. But you need to put in the infrastructure, and then the people that build that are going to look for some sort of a return, and that means you got to at least have a few customers that show up and buy the LNG. You got to get that strategically located, and then you've got to find a way to start that cycle. And I don't think that's infeasible. The economics on these things are pretty compelling, and so I don't think you're going to see nationwide LNG and heavy-duty engines emerge anytime soon. But I think over the next few years, particularly with where gas prices in this country will be, which is very different. Gas is a regional commodity. So gas prices in the United States are the lowest in the world. You've got, if you pay attention to natural gas prices, it's been around $2 per million BTUs. Here recently, if you go to Japan, they're paying $17 or $18. There's an enormous arbitrage between US gas prices and the rest of the world, and liquids prices reflect that. So there's a big payout for somebody on a diesel engine if they could run on LNG. And so I think we'll actually see some money flow into that. And I'm a little more optimistic that in the near term, on a regional basis, we'll see people start to do this. It's a start. It will only, there'll be some limits on how big and how fast it can go, but I actually think that there's a pretty compelling opportunity there.
There's two things that we have to get over first. We have to get over the regional reluctance to have a liquefaction plant sited nearby, and also we have to understand that the United States can and should be an exporter, and so there are some energy security guys that want to keep all of this wealth in the United States. That's not realistic. So you get those two things, and we can get that past that.
Back over here.
Hi there. Many technologies are growing at exponential growth rates, or if not exponential, very close, or substantially more than linear, like biotech, nanotech, computational capacity. And based upon what I heard from you today, it sounds like you're predicting well into 2050 linear growth rates or less on our progression with technology as it relates to energy. Do you see any breakthroughs or anything closer to or exponential growth rate or more than linear in how we'll progress with energy?
Yeah, we've actually because the study that we've done that we're just completing hasn't been presented to the Secretary yet, and it's not done. And I can't really talk about a whole lot about it, but it's not all linear. Now, we're not going to see, Moore's Law does not, first of all, Moore's Law is not a law, number one. It's an observation. And it doesn't, no matter how much you want it to, it doesn't apply to batteries and other things. You can get learning curves, and you can get automation in the factory, but you're not going to see the hockey stick that you're used to seeing with computational power. You're not probably going to see an iPad kind of aha moment with some of the heavy duty stuff. But you will see. We do learn. We're not completely stupid, and we do learn, and we can apply those. And it's less abrupt as you'd want it to be, but it's more. It's stronger than a lot of people think.
Back here on the right.
Diana Hu, Allstate Insurance Company. I have a question regarding the new technology versus old technology, quote unquote. There are old technologies such as train transportation or geo-exchange, which can easily cut your energy consumption, residential energy consumption by 60–70%. So those old technologies, for some reason, their application in this country just seems to be somewhat limited, or have not been taking off as fast as they have been in some other countries. So my question is, do you see anything that makes this country different, that make those technology not so favorable, or is there any paradigm shift that you might imagine that would make those technologies a lot more powerful?
I think let's talk about the bullet trains, because I go to Japan a lot and I ride on the Shinkansen. I travel at 200 miles an hour. I live in Tokyo and commute to Nagoya, which is about like living in Los Angeles and commuting to San Francisco. And I do that on a regular basis. I can walk out of my hotel and literally be on the train in 7 minutes going 200 miles an hour. We will never do that in the United States. Any of you who have been back east and ridden the Acela, that's our idea of a bullet train. and let me tell you, the Acela does not get you from Washington to New York like the Shinkansen. And the tracks are rough because we share tracks. We're not very good at infrastructure now because of our political cycles and our funding cycles. And if Dwight Eisenhower tried to build the interstate highway system today, it would be impossible. It's almost impossible to maintain the interstate highway system today. And I live in California, where we do have probably the number one bullet train idea in the United States, and we've slowly started petering it down and washing it down, and we're doing just like what we paid for the Shinkansen. We're going to get the Acela because they're going to start sharing tracks now to reduce the infrastructure costs, because it's hard for this country to look and take a 10-year funding cycle.
The only thing I would add is, people in this country don't like to be told what to do,
Yeah.
and they tend not to do what the government tells them they should do. Yeah. There are other cultures where you can line up a country and people get in line and get orderly a lot better than Americans. And so it's a matter of this is an enormous geographic spread. The economy of this country is built on a whole diverse set of things, from agriculture to manufacturing to technology, across the expanse of land that we cover. And the U.S. is different than Japan, and it is different than Singapore. And the economy is different, the culture is different, the politics and the society and the behavior are different. And I think those are all barriers to the kind of rapid adoption of some of these things that would require significant behavioral change on the part of a lot of people.
And the economist will add that the prices are lower.
Yeah, that's right.
Yeah, that's true.
My question is for both panelists. Both the auto industry and the oil and gas industry could be defined as mature industries. At this point, they've both seen significant consolidation. Certainly, Chevron and Texaco merged. My question is, common sense would tell us that every industry has to have new players at some point. Who do you think the new players would be, and where do you think they would come from? Because, as Michael said, scale is important in both industries, so it's hard to see new entrants.
So let me I'll put our company in perspective. Fortune, I think, just came out with their most recent Fortune 500. We're number 3 in the Fortune 500. Our market capitalization is in the neighborhood of $200 billion. We produce about 2 million barrels of oil every day, a little bit more when you include gas if you do the equivalency, but we produce about 2 million barrels of oil every day. The world uses 90 million barrels every day. So our market share on a world basis is nominally about 2%. And so it may seem that this is a largely consolidated industry, but we are a minnow. The new players are PetroChina, Sinopec, Rosneft. Saudi Aramco is not a new player, but they're an enormous player. They're much, much larger than we are, as is PetroChina. And so in our business, which requires scale, we've got to have engineers at scale, we've got to have construction capability, operating capability at scale. There are a lot of players that are as big or bigger than a company like ours, which in a US business context is large, I grant you. But at a global level, our ability to influence the price of oil, our ability to influence supply is you know, we're 2% of the market, and we work as hard as we possibly can because oil fields decline every day, and your production naturally goes down as they deplete. Just to hold our production even is an enormous task. So I think there are new entrants, and the other thing that I would tell you is shale gas in this country is a great example. Big companies like Exxon and Chevron are not the ones that created this shale gas revolution. They're the classic wildcatters, the small guys in this industry that find a way to go out into geographies that because we operate big things well, we don't do little things very well. And these guys go out there and they take risks on technology, they take risks on investment, and they're the ones that created the breakthrough that I talked about. And still some of them are leaders relative to companies like ours in that space. And so there's no shortage of new players, of innovation, and of changing competitive dynamics in our industry.
I think you're going to see in the next decade a further consolidation of the auto industry as you know it now. Depending on how you want to count it, we've got 4 markets, maybe 5, that you've got to play in at least 3 of them and be successful. In the existing markets, OECD and EU and North America, we have excess production capacity, so that's got to shift. And we've got weak players that are going to team up with stronger players, and we've got to bring new technologies to the market. So I read today in the New York Times that Mercedes-Benz and BMW, who really fight at each other, are going to work together on some new technologies, or we might work together with other OEMs on new technologies. That's going to happen. What I think you're going to see the new players, and let me say, the cost of getting involved in the automobile industry is huge, and it comes a lot of intellectual property. It comes with product liability and manufacturing capability. It's not easy, and if you want to make $1 million in the auto industry, start with 10 million, and you'll be there. We really have a very small return on investment, as does the oil company. So the new players are probably going to come out of China, out of India, out of Russia maybe, maybe even Brazil. They'll start their own homegrown industries. The hurdle rate they'll have is the intellectual property and how they get their hands on that. I mean, we've got 50 years of backlog of intellectual property of IP. So how they do that is going to be interesting.
One more back here. Any more questions? Well, would you join me in thanking Bill and Mike for a really interesting...
Thanks, Bob.
Thanks, Bill.